Hello everyone, I'm Xiao Gang. In this lesson, we'll take a look at dynamic unicast. Actually, dynamic unicast is much simpler than our regular unicast because it's reflected to Blueprint. Then it can be bound and used in Blueprint. Similarly, it also does not support this. It does not support in the river because it's reflected to Blueprint. This function signature is already written, so you won't be able to dynamically load it. And it might have a bit of a special case. Let me first show you a relatively simple example. Let's first demonstrate a declare, then dynamic. Then let's give it one with two parameters. We won't include the return value, because when it's sorted by this name, it's right here. Then pay attention. The first one is also ours. That is the name of our agent. It must start with a. We call it true. And for this type, we'll keep it simple. We call it comma separated lim. For the second type, we'll give it int_send2. Then call it in lim. It's that simple. Okay, you can see that compared to our single wave, it actually adds the concept of function 0. So how do we actually use it? We also instantiate it here. And here the variable we instantiate is a protected one. Okay, and here we'll call it Delegate to Delegate. Alright, note this. You can see that here we must add a semicolon. You'll notice that if you don't add a semicolon here, it won't pass. Alright, there are some errors here. Right, let's check what the cause of the errors is. This is because of the code I wrote earlier. Delete it. Write test code, okay? Alright, no problem. So how do you use it? Then we definitely have a binding operation like this. Right? And then there is an execution operation. So we can actually write it like this. We call it unit. Let's do dynamic to delegate. Then we can treat it as a. If it's a single broadcast, we can do it directly like this. Right? Doing it this way is completely fine. Okay, then right here we directly make it equal to. So you see, just copy it. And then because here we can use a squared, because it is dynamic. We give it a catograph. Okay, so it's simple and no problem. Then we definitely still need something that can be released. Let's just call it release. We release this delegate. Let's create it. Okay, good. This place here, we can just let it unbind. See, its methods here are actually not that many. Look, BindUFunction. This is one of our methods. It executes. It can retrieve some reflection information. We can just clear it directly like this. We can click to view this comment. That is unbind this delegate. Okay, let's see. This side should also be fine. Good. Then, since this part is relatively simple, we'll just demonstrate it directly to everyone. There's no need for us to write another class. Because the usage is actually the same, we mainly use this method. It is exposed in a methodical way. Okay, for the convenience of demonstration, we will directly create one here. Delegate find out dynamic delegate. Here we give it a BP. We put it under this delegate. Okay, no problem at all. Okay, obviously we can do it here. We can directly find this method here. You can see. Find this method. Okay, compilation is fine. Now we can custom event, right? So we have bound this method. We haven't written the execution yet. Actually, this binding of ours, we can bind it in many places. we can bind it to itself. Here we will not bind it to itself, because if you bind it to itself, you won't know why it's bound to itself again. Then what am I writing this for? So we bind it in the level blueprint. In this level blueprint, we director let it, right? Then this level blueprint. It's just a third-party object. You don't have to be in the level blueprint. You in the game mode, game state, player controller. It can be bound anywhere. You just need to call this interface. Then we instantiate a method here. Then we will accept these two parameters. It's very simple. We will just display A on the screen. This string and this money. Okay, so that's how it's used. So where can we call it? Calling it here might be a bit troublesome. We still need to write another method. Let's just write it here. We can just change the name to call. Obviously, we are passing these two parameters. We can just let it execute directly. Right? We'll just let it execute. This way, we can expose our CJI logic to blueprint, and then extend and improve it using blueprint, instead of being limited because we write all the framework in C++. Therefore, the application of this dynamic singleton is relatively less common, relatively fewer. But with multiple waves, they're basically everywhere. Yes. Then later we will adopt some frameworks to reduce this situation. Then you can see here, you can make a binding. Then let's still use this wanna-click method. Then we'll create one here. We'll name it NPC. Then 998. Actually, this place will fall to this place. We can take a look. NPC 998. This is a dynamic multi-weave, and the difference from our single wave is that you can, in the blueprint, implement its specific word implementation. Because at the C++ level, it's quite troublesome for us. It's very difficult to design this into the UI. Design into UI effects. For example, because you have a large number of assets that need to be configured and set up. Moreover, these things only exist on the client side. On our server, on our dedicated server, no audio is rendered, nor are effects like UI elements. These are all stripped out on the server. This is to ensure the server's scalability. So this is one of its application scenarios. Now, let's write a somewhat special approach for everyone. Right. We should probably go through this part a bit faster. It shouldn't be a big problem. Actually, if you noticed, there is a concept of a return value here. Let's add an R1 here. Take a look. It seems we might need something like this. Because this thing, I don't quite remember it either. This is a really long string, and it's easy to make mistakes. It should be here. Let's just use one parameter. Use one parameter. Let's call it xgun single demigun to return, and then one parameter. Obviously, here we still pass an in-name. Okay, so this is a parameterized dynamic unicast. As for this parameter, we still do it the same way. Let's compile this first. It should compile successfully. The reason for the error here is that we didn't specify the return value. So the way to declare it, the first semicolon is the return value. This is the correct way. Okay, then in this case, we give it a like this. Just now, Dynwinix 1, return 1 delegate. And this is actually the same. It's the same. But the way it's handled in Blueprint might be different. We can just rename it here. Actually, there are some more complex ways to write this. We haven't covered them yet. I'll explain them later when there's a chance. because that is a bit more complicated. It involves things like generic types and async. If you want to write advanced nodes like this in Blueprint, it's a bit complex. We can't cover that now. Okay, so here, we can just make it way here. Note this parameter. It is 1. Here it is, 1. This way, we can make it wait. Obviously, here we just clear it. Here in toxic clear. Where would we use this kind of approach? If you have used if you have used a voice placar or speech recognition, you will find that we carry this thing inside this subsystem. We haven't talked about subsystems yet. We'll have to put it off until later. Okay? A subsystem is a singleton. It's actually very simple too. But this singleton is very powerful. So let's change this delegate. Here we only need one parameter. We don't need this money. These people say, okay, here we change the function signature. So we can change this part. Let's jump back and forth between these two files. This might be better this way too. Okay, then that should work. Now let's. Here. It doesn't have a semicolon. Okay. Okay, no problem. Okay, so for this thing of ours, we won't bind it in the level blueprint because it's the same thing. There's no need to do it repeatedly. Let's do it a different way. Okay, we'll just bind it within itself. We'll bind it right here. We could absolutely bind it in the level blueprint or in other actors. That would be perfectly fine. But why are we still binding it here? This is mainly for our convenience in writing. It just means capturing an instance of this actor one less time. Here, we call it xg. Unit 1. Okay, you can see that the compilation here is fine. But if you use a custom event here, you will find it reports an error, right? Because it has a return value. And here you don't have a return value. The function signature cannot match. So we actually match it evenly in this way, right? Let's print out the name. Then we switch back to a 99. Okay, where is this 99 received? Actually, it is received here. In our place. Here we can receive a 99. You see, right here, it doesn't seem to give me a prompt here, but it should be receivable here. Then we implement it like this. You can change this function signature, change the name, but let's just use this long and cumbersome name. Then we call it in our observation blueprint. Let's use a 2 here. And here, let's directly expand this one. We input this name, false. Okay, let's align this here. You see, the boss appears here. Actually, this place can accept a sig its return value. That is, we input 99. Good. Well, for a single wave, the entire usage process is roughly like this, relatively simple. Yes, because dynamic single waves are used relatively rarely, because it can only do one-to-one. But the advantage is, it can receive return values, and when writing it, the syntax is relatively special. Yes, okay, let's stop here. This is our dynamic unicast. There might be some other methods. Everyone can check them out on their own, because compared to our unicast, it is much simpler because it exposed to Blueprint. He does some simplification and optimization. Okay, thank you everyone.